Welcome back. In this section, we continue our journey through Chapter 4. We have already covered the coordinate plane and basic lines. Now, in this specific lesson, we will thoroughly explain Section 4.3, Slope, Section 4.4, More lines, and Section 4.5, Inequalities. Let's master these concepts. The slope or gradient of a line is a measure of its steepness. The slope of a straight line is the ratio of the vertical change to the horizontal change between any 2 points lying on the line. The vertical change is often called the rise, and the horizontal change is often called the run. Therefore, slope is given by the formula rise over run, or delta y over delta x. Let's look at an example. A line passes through 2 points, P1 at 1, 2, and P2 at 5, 5. Let's find the slope using the coordinate formula. We substitute the coordinates into the formula, y2 minus y1 over x2 minus x1. This gives 5 minus 2 in the numerator and 5 minus 1 in the denominator. Simplifying the fractions, we get a rise of 3 and a run of 4. So, our final slope m is exactly 3 over 4, which equals 0.75. Since the slope is positive, the line goes uphill from left to right. To find the slope of a line passing through 2 points, we use the standard slope formula m equals y2 minus y1 over x2 minus x1. Simply substitute the given coordinates into this algebraic expression. Once we find the slope, we can easily draw the graph by plotting the 2 points and joining them up with a straight line. Let's solve example 1. Find the slope of the line that passes through the points 1, 1, and 4, 5, and draw the graph. Let's substitute the values into our slope formula. In the numerator, y2 minus y1 gives 5 minus 1. In the denominator, x2 minus x1 gives 4 minus 1. Simplifying this expression, we get 4 over 3. So the final slope of the line is exactly 4 over 3. When a coordinate contains an unknown variable like k, we can still find its value by applying the standard slope formula. Let's substitute the coordinates into the formula, set it equal to the given slope, and solve the equation step by step. Let's solve a similar practice problem. If the slope of the line that passes through the points 2, 3, and 5, 3k is 2, find the value of k. First, substituting the values into our slope formula gives 3k minus 3 over 5 minus 2. This simplifies to 3k minus 3 over 3. Since the given slope is 2, we can write the equation as 3k minus 3 over 3 equals 2. Multiplying both sides by 3, we get 3k minus 3 equals 6. Adding 3 to both sides gives 3k equals 9. Finally, dividing by 3, we find that k equals 3. If we know the slope m and a specific point x1, y1 on a line, we can determine the complete equation of that straight line. Let's geometrically derive why the point slope formula works from the fundamental definition of slope. By definition, the slope m between any 2 points on a line is the change in y divided by the change in x. For our fixed point x1, y1, and the generic point x, y, the slope can be expressed as y minus y1 divided by x minus x1 equals m. To eliminate the fraction, let's multiply both sides of the equation by x minus x1. As a result, we successfully derive the point-slope formula, y minus y1 equals m times x minus x1. Let's practice finding the equation of a straight line using the point-slope formula. When we are given a specific coordinate and the slope of the line, we can substitute these values directly into the formula, y minus y1 equals m times x minus x1, and simplify it into its standard algebraic form. Let's solve our practice problem. Find the equation of the line through the point 3, -2 that has a slope of -2. Here, our fixed point x1, y1 is 3, -2, and the slope m is -2. Substituting these into the formula, we get y minus -2 equals -2 times x minus 3. This simplifies to y plus 2 equals -2x plus 6. Finally, rearranging the variables to the left side, we get 2x plus y equals 4. This is our final equation of the straight line. Parallel lines are two or more lines in a plane that never intersect or cross. No matter how long you draw them, they will never meet. We use a special symbol with two vertical bars to indicate that lines are parallel. Let's look at how this appears on a coordinate plane. Let's define the mathematical notation. If line L1 and line L2 are parallel, we read this as line L1 is parallel to line L2. Algebraically, parallel lines are very special because they always share the exact same slope. This means if line L1 has a slope of m1 and line L2 has a slope of m2, then m1 must equal m2. Vertical lines are parallel to each other, but they have a very unique property. Their slopes are completely undefined. Let's explore algebraically and geometrically why the slope of a vertical line cannot be defined. Any 2 points on a vertical line will always have the same x-coordinate, which we can call C. So the points look like C, y1 and C, y2. When we substitute these into the standard slope formula, the denominator becomes C minus C, which equals 0. Because dividing any number by 0 is undefined, the slope m is not defined. Two lines are perpendicular if they intersect at a perfect 90-degree right angle. Algebraically, their slopes have a very unique relationship. The slope of one line is the negative reciprocal of the slope of the other. Let's break down what this means mathematically. To get the reciprocal of a number, you divide 1 by that number. For example, the reciprocal of x is 1 over x, so its negative reciprocal is -1 over x. Therefore, if two lines L1 and L2 are perpendicular, the product of their slopes, m1 times m2, must equal -1. Let's see this visually. To find the equation of a line perpendicular to another line, we first need to determine the slope of the original line. Then, we find its negative reciprocal to get our perpendicular slope. Finally, we apply the point-slope formula with our new coordinates. Let's solve the practice problem. Determine the equation of the line passing through 4, 3 that is perpendicular to the line through 1, -2 and 3, 2. Step 1. Find the original slope m1. The difference in y over difference in x gives 2 minus negative 2 over 3 minus 1, which equals 4 over 2, or exactly 2. Step 2. Find our perpendicular slope m2. Since m1 times m2 equals negative 1, 2 times m2 equals negative 1, giving us a slope of negative 1 over 2. Step 3. Use the point-slope formula. Substituting the point 4, 3, and our new slope, y minus 3 equals negative 1 over 2 times x minus 4. Multiplying both sides by 2 and rearranging the terms, we get our final equation x plus 2y equals 10. The slope-intercept form is one of the most common ways to express a linear equation. In this form, the variable y is isolated on one side of the equation. Let's mathematically prove why y equals mx plus b represents a straight line. To prove this, let's start with a line that has a slope of m and crosses the y-axis at b. This crossing point means the line passes through the fixed point 0, b. Now let's apply the standard point-slope formula, which is y minus y1 equals m times x minus x1. Substituting our point 0, b into this expression gives y minus b equals m times x minus 0. Simplifying the right side gives y minus b equals mx. Finally, adding b to both sides isolates y, leaving us with y equals mx plus b. The formula is beautifully proven. To plot the graph of a linear equation in slope-intercept form, we begin by identifying the y-intercept and plotting that point first. From there, we use the rise over run definition of the slope to find a second point and connect them with a straight line. Let's solve our practice problem. Plot the graph of y equals 1 over 3x plus 1. First, comparing this with y equals mx plus b, the y-intercept b is 1, so we plot the point 0, 1. Next, the slope m is 1 over 3. This means for a slope of 1 over 3, we go up 1 unit for every 3 units across. Starting from 0, 1, moving 3 units right and 1 unit up brings us to the point 3, 2. Now let's see how to plot this on the coordinate plane. When a linear equation is given in general form, we can find its slope and y-intercept by converting it into slope-intercept form. To do this, we isolate the variable y on one side step by step and then simply read the coefficients. Let's solve the practice problem. Determine the slope and y-intercept of the line 3x minus 4y equals 8. Step 1. Solve the equation for y. Subtract 3x from both sides to get negative 4y equals negative 3x plus 8. Next, divide everything by negative 4. This gives y equals negative 3 over negative 4x plus 8 over negative 4. Simplifying the signs, we get y equals 3 over 4x minus 2. Step 2. Extract the values. The slope m is exactly 3 over 4, and the constant term is negative 2, meaning the y-intercept is 0, negative 2. Let's graph this line to see the final result. Since parallel lines share the exact same slope, we can find our new line's equation by extracting the slope from the given line. Then, we substitute the slope along with the new coordinates into the point-slope formula. Let's solve the practice problem. Find the equation of the line through 2, one that is parallel to the line 3x minus y equals 4. Step 1. Rearrange the given line into slope-intercept form to find y equals 3x minus 4. This shows the original slope is 3. Step 2. Since the required line is parallel, its slope must also be exactly 3. Step 3. Apply the point-slope formula. Substituting our point 2, 1 and slope 3, y minus 1 equals 3 times x minus 2. Expanding and rearranging the terms, we get our final parallel line equation, 3x minus y equals 5. Two lines with the exact same slope can either be parallel or coinciding. If their y-intercepts are different, the lines will never meet and are parallel. However, if their y-intercepts are also identical, the two lines lie exactly on top of each other. Let's compare two examples with a slope of 2. First, look at y equals 2x plus 1 and y equals 2x minus 3. They have the same slope but different y-intercepts, making them parallel. Second, consider y equals 2x plus 1 and 2x minus y equals negative 1. Converting the second equation gives y equals 2x plus 1. Since the slope and y-intercept are both identical, these lines coincide completely. A single line divides the entire two-dimensional coordinate plane into 3 distinct regions. First, the set of points that lie exactly on the line. Second, the region of points that lie strictly above the line. And third, the region of points that lie strictly below the line. Let's practice with the linear equation y equals x plus 1. The points on this line form a boundary and satisfy y equals x plus 1. Since the boundary line itself is not included in the strict inequalities, the line will be drawn as a dashed line. The area above satisfies y is greater than x plus 1, and the area below satisfies y is less than x plus 1. To sketch the region defined by a linear inequality, we first plot the corresponding equation as our borderline. Then, to decide which side to shade, we test a simple point like 0, 0. If the statement is true, we shade that side. If false, we shade the opposite side. Let's solve our practice problem. Sketch the region defined by 2x minus y is greater than 1. First, the borderline equation is 2x minus y equals 1, which simplifies to y equals 2x minus 1. Next, let's test the point 0, 0. Substituting x equals 0 and y equals 0 gives 0 minus 0 is greater than 1. Since 0 is not greater than 1, this is a false statement. Therefore, 0, 0 does not lie in our region, so we shade the opposite side of the line. Inequality regions can have different types of borders. A strict inequality using greater than or less than signs does not include the border, so we draw it as a dashed line. However, inequalities with greater than or equal to or less than or equal to do include the border, so we draw it as a solid line. Let's visualize this using a custom example. Y is greater than negative x plus 2. Because this is a strict inequality, we sketch the region above the line and make the border dashed. Now, if we change the sign to greater than or equal to, the boundary line's points are now included, and the dashed line transforms into a solid line. Let's solve a similar practice problem step by step. To sketch the region for the inequality 3y is less than 3x plus 6, we first convert it to a standard boundary equation. Then we check a test point to find the correct side to shade. First, let's form the borderline equation. 3y equals 3x plus 6. Dividing both sides by 3 gives y equals x plus 2. Since the sign is strictly less than, the line will be dashed. Now, test whether the point 0, 0 satisfies the inequality. Substituting x equals 0 and y equals 0 gives 0 is less than 6. This is a true statement, so 0 lies inside our solution set. A system of linear inequalities consists of two or more inequalities. The solution to the system is the region that satisfies all inequalities at the same time. To graph this system, we find the overlapping area where the individual regions intersect. Let's solve a system with two custom inequalities. Y is greater than x minus 1 and y is less than negative x plus 3. We will graph the first region, then graph the second region, and finally locate the exact boundary where they completely overlap.